fun. Draw. So I mean, we have multiple conjectures floating around. Someone says concavity is relevant. Someone else says
no, it's irrelevant.
Yeah, I think if we draw some pictures, pictures kind of worth 1,000 words here. In fact, maybe the thing to do is to just draw some functions with no concavity, right? How about I just draw just some straight up increasing function, on the other hand, some straight up decreasing function. Maybe I need to draw like 4 pictures, right? So, yeah, if this function is increasing, if I go and try to do LRAM, what happens? What happens? This is going to be an underestimate, right? And if I do RM, overestimate. And that is the opposite of what we saw, right? On the frontboard, with the decreasing function, if I do LRAM, it'll be an overestimate. And if I do RM, it's going to be an underestimate. And it's actually, okay, so on the one hand, the answer is duh, because just like look at it, there it is. On the other hand, it's actually possible to really like maybe talk deeply about what this means, because after all, what is going on here when we use RM? When we use RM, so this is the RM, did I even do this consistently? No, I didn't. This is RM, this is LRAM, this is RM. Excellent chart I have here. And this is LRAM. Okay, so when I use RM, what I'm really doing is I am supposing for each subinterval that the behavior of the function at the right-hand endpoint of the subinterval is representative, right? I'm essentially going subinterval by subinterval and saying, well, I'm not sure what this function is doing on this interval, but let's just say whatever it happens to be doing at the right endpoint is more or less what it's doing over the whole interval. But of course, as this is an increasing function, it's going to be the largest on each. You take this on a subinterval by subinterval basis. The rectangle whose height is determined by the value of the function at the right-hand endpoint is going to be larger than any other rectangle I might draw because the function's increasing, so it's getting bigger and bigger. Does this make sense? And like conversely, over here, as the function is decreasing, I'm estimating on a subinterval by subinterval basis. I'm estimating. I'm saying, well, on this subinterval, let's just say that the function is doing whatever it's doing on the right-hand endpoint. Well, since it's decreasing, then that's totally giving an underestimate. So on a rectangle by rectangle basis, that shows that this is going to happen. Okay, cool. Let's do it. So the problem is, there are a couple problems here. Some of you might get mad at me. But one problem here is kind of annoying, right? Because, well, let's just do what we did before. What are all these endpoints? Like, what's that one? Yeah, so that's just like 0, right? That's just like 0, comma, f of 0. Okay? Sure. How about the next one? Wait, can we go like faster? Some of you are like done already. So yeah, this is going to be like, we kind of did this already, right? I'm just going to look over here. This is 1 times 2/5, comma, f of, comma, let's just say f that, because that's like fun. F of that. So like, you know, f that. And then the next one is like, well now I've scooted over like 2 rectangles, right? Or I've scooted over 2/5 twice. That's 2 times 2/5, comma, f that. 3 times 2/5, comma, f that. And 4 times 2/5, comma, f that. Okay. And then over here, if I want to keep the pattern, I could write this as 0 times 2/5, comma, f of that. All right, and you guys kind of see what's going on here? Like it's like a little bit annoying, right? Because now the first rectangle is determined by that number's like a 0 now. They're like not matching. It's like a comp sci thing, right? It's like the loop is not matching nicely. Okay, so how are we going to write this? I don't know. Can we just do it? What's the sum? Someone just start talking.
2/5 plus 0 times 2/5.
Yeah.
Plus 2/5 not that, but one of them